Okay, this is the test corrections video. This is a little mock-up of what you should have in front of you right now, which is like a test corrections kind of packet. We should have all the numbers of every question on it and sort of a setup roughly like this. This is my rough draft, but you'll have a more finalized version. So my expectations are, just to be super clear, is that you go through each question. You're going to go through and say, okay, I got it wrong or I got it right. Okay, so you would select, if it's correct, okay, you're done. Like, you don't need to do any more. As long as you understand it, you're good. If you got it correct, you don't know why, fill it in. But if you got it incorrect, you gotta circle that. You're gonna explain the why, and then you're gonna write the correct version. So for example, if I was looking at 1, which I've already done this, already recorded the video, but you'll see in a second. Maybe you got it wrong because you forgot about the 200. You forgot to add the 200 at the beginning. So you would say right here, I forgot initial value 200. I want you to be as detailed as possible in here and explaining the why. And in the correct version, you would say, okay, well, it's going to be 200 plus the integral from 0 to 4 of our t dt in calculator is 175 degrees. Right, that would be one for number 1. Okay, just to be clear. Okay, that's it. Enjoy the video. Okay, this is the corrections video, so I'm going to be going over the Unit 3 test in detail here, and I'll have made a part of the video before this talking about the correction sheet and the expectations. Follow along with the correction sheet and mark your mistakes and mark your reflections on for each question that you got wrong. Okay, I'm on version A, but every question that I do, if you had a version B, I'm just going to mark which number that was on B. So if you're in version B, we're starting with 3 and so on. You can just look at the B marker to see what number to go to. Okay, first question of the test was, a cup of tea is cooling in a room that has a constant temperature of 70 degrees Fahrenheit. If the initial temperature of the tea at t equals 0 minutes is 200, find the temperature of the tea, and the temperature of the tea changes at the rate R of t equals negative 6.89 e to the negative 0.053 t degrees Fahrenheit per minute. What is the temperature to the nearest degree of the tea after 4 minutes? So key here is the initial. See here, initial temperature. So you know at t equals 0, we're at 200, so we're starting at 200 degrees. And then, to get the change in temperature, I need to take the integral of the rate. So I'm going to take the integral from where I started, the 0, to where I end after 4 minutes of r of t dt. Okay? So let's do that. So in the calculator, that would be negative, I don't need to go there, it's just going to be math 9, since I'm only using it one time, negative 6.89 e to the power of, and then parentheses, oh, it's already done parentheses for me, negative 0.053x. Close it. And then comma x, comma 0, comma gamma 4. Is that okay? Enter. Plus the 200. So it comes out to 175.3, right? Which is to the nearest degree, so it must be 175. Other thing to know here is like the 70, you might have been confused by 70, but this is just sort of context for the problem. It has nothing to do with the actual evaluation. Okay, 2, which is B4. The function h is given by this integral for 1 to 7. On what intervals, if any, is h decreasing? So if I want to find where h, this is h, where that is decreasing, I need to find out where is h prime of x, the derivative, where is that negative? Well, what is h prime of x? H prime of x is just this inside expression here, right? So, calculator, put it in, ln x sine, okay, x sine x, close it, plus 5. I think some of you may have struggled with like putting this one in the calculator. I put this on the board on the task to make sure you understood. But if it's not inside like a second pair of parentheses in here, this is not saying sine t plus 5, it's sine t plus 5. I know that's kind of confusing. So it should look like this. We're closing out that sign right there. Okay, I'm just gonna put the window right, 1 to 7, which already is. Let's have a look. So where is this decreasing? Where is it negative? Right there. Now, to get the exact points, I can do second and then 0, and then left would be here, right is down here, and then in the middle, and that is 4.3. So I can see, okay, it's from 4.3 to some value right here. Looks like it's for like 5 point something. So I can see, without even like doing any more, that it's going to be B, right? But if I went on here and I did that, and I did 0, and I went over to the left side, same thing, enter, 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 sorry, middle, it would be 5.4. So yeah, absolutely going to be B. 3. A particle moves along the x-axis, so its velocity t above 0 is given by this. So v of t equals t squared minus 1 over t squared plus 1. That is a plus. So sorry if that wasn't clear. I'm going to try and fix that in the next test so it's a lot clearer on the printing. Sorry about that if that was not clear. What is the total distance traveled from the particle from t equals 0 to t equals 2? Okay, so total distance indicates, when you see total distance, right, you know this is the integral, not of just velocity, but the integral of speed, right, from some a to b dt, right? So my integral is going to be from 0 to 2 of the absolute value of t squared minus 1 over t squared plus 1 dt. Okay, so in the calculator, similar thing here. I'm gonna go ahead and put it in for y1, and then I'll bring it down. I just want to show you, because I think again some of you may have made mistakes here. Some of you may have done this. You might have done x squared minus 1 divided by x squared plus 1. This is incorrect. Like, this is not going to get you the right answer. You have to make sure in fractions that you're putting it in parentheses in the top and bottom. If you're using like a Neuro calculator, there's actually a function for this, which makes it a lot easier. I think it's alpha y equals. If you're on a Neuro calculator, that can get you like a fraction thing. But this is what you want. And then we will go back here, and now I'll take the integral. So we do math 9. Math 9. Now I need to also take the absolute value. So here we do math num absolute value of y1. Now you could have put the absolute value in y1, and then you wouldn't have to do it here, but it has to go here, comma x, comma 0, comma 2, and when I do that, I'm gonna get 0.927 right there. It's D. Okay, so again, key thing here was total distance, indicating absolute value. Okay. Let f of x be an antiderivative of ln x to the third over x. If f of 1 is 0, that's not good. If f of 1, I'm going to zoom in like this. If f of 1 is 0, then what is f of 9? Okay, well this is an initial value problem, right? This is my starting value here. I need to find the ending value. This is like my starting time. This is my ending time here. And this is my rate, right? This is f prime of x. Because if that's the antiderivative, that must be the rate. So we do, my starting value is 0, that makes it easy. 0 integral from 1 to 9 of ln x to the third over x will get me this. So let's do it on the calculator. Math 9, ln x to the third over x. So ln x 3. I'm going to put this all in parentheses. I think it's fine without, but I'm going to do it just to be safe. Divided by x, comma 1, comma 9. Enter. 5.827. So it's C there. Okay. Because I don't have to add anything because it's 0. The starting value is 0. Okay. Particle moves along the x-axis so that at any time t greater than or equal to 0, its velocity is given by cosine 2 minus t squared. The position of the particle is 3 at time equals 0. Okay, that's, this is like something you should really look for. Okay, this is like an initial value. I know it's going to be 3 plus something, right? 3 plus something. What is the position of the particle when its velocity is equal to 0? So I start at 3, and I'm adding an interval, and we're starting from 0, right? 0 is right here. But what is the position of the particle when its velocity is first equal to 0? So this right here, my upper bound, is unknown. Some of you might have put, but I think I saw a lot of people kind of struggling here, and like trying to find what to put here. And obviously v of t is going to go here. V of t dt will go here. The question is, what goes here? You had to work this one out through this question. What is the position of the what is the position of the particle when its velocity is first equal to 0? So we need to find when its velocity is first equal to 0. To do that, we have to graph it. So here on the graph, cosine is going to be cosine minus cosine 2 minus x squared. Close it. I'm going to graph. Let's do, what's my window right now? Let's do window from like 0 to 5. We'll see what it looks like. So can't really see what's going on here, but it looks like it definitely crosses right there. Let's kind of zoom in on that a little bit. I'm going to make my new x max like 2.5. I can see this. So again, this is velocity. I'm graphing velocity. When is it first equal to 0? Right there. That's where it's first equal to 0. So we need to find that point. We'll do 0, 1 on the left, one on the right, 1 in the middle. 0.655. So I'm going to write that off to the side. This right here should be 0.655. Now I can do my interval. So it's going to be back to home, math 9, y1, so vars y1, comma x, comma 0, comma 0.655. Close it, plus the 3 at the end, 2.816. 2.816. So this one is very similar. You just had to find this value through this language here. Okay, 6. B5. For t greater than or equal to 0, the velocity of a particle moving along the x-axis is given by v of t equals t to the third minus 6t squared plus 10t minus 4. At what time does the direction of the motion of the particle change from right to left? Okay, so graph it. I need to figure out where it's crossing the x-axis. I have velocity already. Let's just graph it. We're going to have x to the third minus 6x squared plus 10x minus 4. Let's change my window a little bit. I'll expand it out to 5. Let's see what's going on. So I'm looking for where it's changing from right to left. So this is moving to the left, that's moving to the right, that's moving to the left, right. So where does it go right to left? This one right here, which looks like 2, but let me just make sure with the 0 on the left, on the right, in the middle. 2. It is 2. So that's it. 2. Okay. All right. The FRQ, where most of you struggled, most everybody lost most of their points on the FRQ, specifically the second one. You all did mostly okay on this one, relatively speaking. Okay, particle moves along the x-axis so that its velocity is given by this. Okay, we got the velocity right here. At time equals 0, initial position is 7. Okay, so starting position right here, so maybe for the future I need that. First one, find the acceleration of the particle at t equals 3.1. Is the particle speed increasing or decreasing at this time? Now is a really good time. Calculate a question. I'm going to be using this the entire time. Let's put it in for y1 so I don't have to keep doing it over and over again. And again, the same mistake I think I saw people make on the calculator. X to the 6th minus 13 x to the 4th plus 12, all in parentheses, all in one big parentheses because it's in the numerator, divided by, in the bottom, 10x at 3 plus 3. Okay, I got it. So it's in y1. Now I'm on A. Find the acceleration. So you had to know the acceleration, to find acceleration equals velocity. So you had to put this. V prime of 3.1 equals A of 3.1 equals. Now I'm going to do it in the calculator. So math 8. Y1 comma x comma 3.1. Enter. 1.519. And I'm not given any units, so don't worry about that. Okay, that would be a point, right? A point. That is, again, if you're doing anything other than what it was originally giving you, you have to explain what you're doing. This was not okay. You cannot just say A of 3.1. You have to say, how did you get there? And you can't say A of t. You can't say that. You have to say A of 3.1. You have to be very specific. So this was very, very important here, and putting the 3.1 in, very, very important. Is it, now we're on the second part. Is this particle speed increasing or decreasing? To know that, you got to look at the acceleration and the velocity. So down here below, we're just going to find the velocity at 3.1. And that is easiest way to do that with the calculator. var is y1, parentheses 3.1 was negative 1, really, on the dot. Negative 1 on the dot. While I'm here, test B was slightly different. If you're looking at test A right now, it's the same exact thing except different number, right? So just, you know what to do. You saw me do it. Just put in 5.1 in. Is the particle's speed increasing or decreasing? The particle's speed is decreasing at t equals 3.1 because A of 3.1 and V of 3.1 are opposite signs. This would be a perfect answer to this question. The version, here it is, the version B was the same idea except it was 5.1 instead. So it would be the exact same format here. You would have done 5.1, just plugging in 5.1 in here instead. So we can do that, right? Just to double check. This would be 5.1, which was 6.4, and the y bars would be also 1. So see here, they were both positive. This is acceleration, that's velocity. but since they were both positive, that one would have been increasing. So if you had version B, it was increasing and it was these numbers. Okay. Moving on. I think that was the only difference. Find all the values of t in the interval 0 to 2 where the speed is 1. So you got to understand, you should have written this, what is speed? Speed is the absolute value. Sorry, let me just say it in math. Speed is the absolute value of velocity. Point right there. That's a point. Just for saying that, that should have been a point. Okay, so that's one of your points here. Let me I'll go back up here for a second. This was 1 point for acceleration. This is 1 point for velocity. This is 1 point for your answer and justification. Here, just saying that speed is the absolute value of velocity, 1 point. Which, by the way, this is how it should be graded. This is not necessarily how I graded yours. I was definitely a lot more generous with this. You got to say that. Okay, so we're looking for where does that equal 1, right? We're looking for where does that equal 1. And so let's go back to the calculator for a second. Easiest thing to do right now is just make that 0 to 2, change the window. Now remember, absolute value. So for those of you who have like the newer calculators, it's actually really hard to add the absolute value back into this. So a really helpful thing I would say is just do on a new one, math, abs, and then put in y1 right here. And then turn this one off back here by clicking the equal sign. So now it's just going to graph the absolute value of y. Okay, graph it. See what happens. Oh, I need to add one more thing. There it is. Let's go back here though. I need to add 1 because I need to find out where it equals 1. Good. And then we go second and then intersect. And then first curve would be right here. So we have 0.772. So this would be t equals 0.772. And then same thing, intersect the other one. Enter 1.401. Or 00 is fine as well. This is it. So that's one point there, and this would have been the other point. I think many people wrote just 0.772, but not this one. Also, a lot of people just wrote 0.772 with no context. They didn't say t equals, they just wrote that number. Can't do that. You have to be specific. You have to label things like this, right? Like this. Okay, C and D, let's get on with it. First, find the position of the particle at t equals 4. Is the particle moving toward the origin, away from the origin, at time t equals 4? Justify your answer. So, where is it at t equals 4? Well, I know I began at t equals 0. I was at 7 back at the top. So this is the initial value coming in. We have an integral from 7 plus the integral from 0 to 4 of v of t dt. Let's do it. So I should have done math 9. Sorry, back home. Math 9 y1 comma x comma 0 comma 4, close it, plus the 7 at the end. Plus 7, 6.712. So that's my position. In order to find if it was moving toward or away, we also need velocity here. So we need velocity of 4, which again, easiest way to do that is just vars, y1, parentheses 4, and it is positive 1.213. So it is moving away from the origin. The particle is moving away from the origin because both position and velocity are positive. Okay. And then if we grading this wise, this would have been a point. This expression would have been a point. This point, and then this point. Okay. Last one, and this one was tough, guys. This one was tough, and I don't know if anybody got this one correct. During the time, the interval 0 to 4, does the particle return to its initial position? Give a reason for your answer. So, and I gave you a hint, which was the intermediate value theorem, and considering G of 1 and 4. So, and this meant position. I don't know why I said G. It should have been it should be S of 1 and S of 4. That was a mistake. I think I clarified that in the test. Does it return? Well, I know its initial position is x equals 7. X equals 7 is the initial position. So the question is, does this particle go back here at some point? Does it come back to 7? And we can prove this by looking at these two positions, S of 1 and S of 4. So S of 1 would be, there's a number of ways to prove this. This isn't the only one. But S of 1 would be 7 plus the integral from 0 to 1 v of t dt, which is, let's go back up here. Nine 0.4, and I already know that S of 4 was 6.7. 1, 2. So see here, oh sorry, 9.404, my bad. So see, at 1, the particle moved to 9.04, and by 4, it's backed down to 6.7. So see how 7's between both of these? That means it must have crossed, it must have returned to its initial position by crossing through here. Okay, so you would have to stay off to the side. Since S of t is continuous over 0, 4, and S of 1 equals 9.404, and S of 4 equals 6.712, and 7 is less than, S of 1 is greater than S of 4. The particle must have returned to x equals 7. Let me read that again. Since S of t is continuous over 0, 4, S of 1 equals 9.404, and S of 4 equals 6.712, and S7 is greater than S of 4 but less than S of 1, the particle must have returned to x equals 7 in that interval. Okay. Again, like this is a tough one. I'd say like getting this would be like you're getting a 5. If you're getting this question, you're getting a 5. That's the truth, right? You're going for the 5. These ones are definitely these are staples, if that makes sense. And then sometimes it'll be like just a weird kind of question like this, which will make you think more. And this is more for like, okay, you're going for the 5. So these are more like, you're getting these, you still got a 5, but you have to get more of these. That makes sense. Okay. That's it for calculator. Okay, part 2. No graphing calculator. Here we go. So no calculator needed for this. I think big picture that kind of hurt you guys, because I saw some of you with your calculator doing these problems like frantically trying to figure out what to do, and in a way knowing that you have no calculator. Like I let you use a calculator for like arithmetic, but it wasn't going to help you on anything else. Like it was gonna kind of hurt you. I think obsessing over the calculator on this portion only hurt you. So I would recommend when it says no calculator, genuinely do not use a calculator unless you're like adding some numbers like 5. That's the only time it's going to be helpful. There's nothing else it can be helpful for. The figure above shows the graph of the continuous function g. So this is also b equals 1. When is it increasing? Okay, so again, increasing is when the derivative is positive, and the derivative in this case is just g of x, which is this. Where is it positive? 0 to 1 and 3 to 7. So the answer is C. Okay, it's positive here and it's positive here, and those are the intervals are 3 to 7 and 0 to 1. Okay. 2. Ugh, 2. You guys killed me with 2. So many got this wrong. So many. I think very few got this right. Many got half credit. Many got half credit because you understood part of it, but you didn't understand all of it. Many of you got this part. Like you did. Let me refocus this. Focus. There we go. Many of you got the combination of these. So saying, okay, well, if 0 to 3 is 6 and 3 to 5 is 4, then that means that the integral from 0 to 5 of f of x is 10. So a lot of you got to that point, and to that I gave you like some half credit, okay, partial credit. But you didn't get to the end because it's not asking for this. So 10 is not right. It's not asking for 10. It's asking for the integral of 3 plus 2 times f of x. So 2 times f of x, immediately that would turn that into 20, right? So really we have 20, okay? So you might think, oh, it's 20. But there's a plus 3 here. And so many of you thought, oh, it's just plus 3. Many people put 23. Incorrect, not 23. Why is that? Because it's not the integral of 2 f of x, close it, then plus 3. It's literally the integral of 3 plus 2 times f of x. So what that means is this is an area. This is not 3. This is the area of 3 from 0 to 5. It's this area here. It's the area of the rectangle. What's the area of that rectangle? 3 times 5, right? Because this is a length of 5 right here. That's the 5. And a height of 3. That's 15. So let's break this down. This is really saying the integral of 0 to 5 of 3 plus 2 times the integral of 0 to 5 of f of x. I broke it down into 2 parts. Put the dx here, dx here. Okay. This, we already determined that is 10. So this is 2 times 10, which is 20. And here, the integral from 0 to 5 of 3. Different ways to do it. You could also do this fundamental theorem of calculus style. Antiderivative, 3x, 0 to 5. 5 times 3 is 15. And then minus 0 times 3 is just 0. So anyway, you have 15. You can do it 2 ways. You can do it the visual way, or you can do it fundamental theorem of calculus, but your answer should have been 35, and so few of you got this wrong. I'll tell you right now, this question, another one just like it on the next test. I can guarantee you that. Another question just like this one, so be ready for that, because so many of you missed this when you shouldn't have. Next one. Weirdly, more of you probably got this one than the last one. Weirdly, because this one is a funny one. Also, like appears a lot on the test, but it's like a one that you just memorize the trick to almost. So in this, getting into summation form, it should be b minus a over n would be your first part. So 6 minus 2 is 4 over n. So you know that your width is 4 over n, so immediately you could eliminate the 6 over n's, which I saw many of you do that. Okay, you got rid of the 6 over n's. Then on the inside, it should be your initial value, so it's going to be f of your initial value a plus that same b over n k. Should be on the inside. So you're going to put your a into that. So the 2 goes into that. See that? That's a 2 right there. And then plus that same width times the k. So it's C. Answer C. Okay. The graph of the differentiable function h of x is the integral from 0 to x, which the following is true. So this is, it's a classic one. You're basically identifying the signs of these different ones and putting them in order. So we plug in it. First thing you do is you just plug a 6 into the integral. So you're just getting the area from 0 to 6. It's all this. And it's clear, right, that h of 6 is a negative value because it's all negative here. That means that it must be either a or b. I know that immediately because they're the smallest ones, right? This is going from small to big. Then we've got the derivative of 6, which is just the value, right? This is the same as saying, what is f of 6? Remember, this is f right here. F of 6 is 0. So that's 0, so that's going to be in the middle. And then the last one, the second derivative of 6, is the same as the slope of f at 6. The slope here, you can see the slope is positive. So that would be the biggest one. So it has to be A. Okay, moving on. This is another one that I think many of you got right, but I don't think you know why. I think a lot of you just lucked on this one from the look of it. I don't know if you understood why. This is relatively easy. The table shown gives, so we've got a table of different values. What is the value of this? Well, what does this mean? So this is the same as f of x, right, from, which is the antiderivative, from 2 to 7, which is the same as f of 7 minus f of 2. This is fundamental theorem of calculus right here. Let me be clear. This is the fundamental theorem of calc part 2. That's what this is. Okay. It's taking the antiderivative, vertical line, 2 to 7, and then the difference. So what's f of 7? F of 7 is 5. F of 2 is 1. 5 minus 1 is 4. The answer is 4. Okay. Next. I like this problem. Second derivative is this. What could be the first derivative? Or it could be the original function, rather, not first derivative. So there's actually kind of a number of ways that you can do this one, and I saw people trying it a number of different ways. I saw people integrating it, which is cool, and I saw people like testing these, which was cool. You can kind of do this one through like kind of almost, this is a problem where it's almost easier just to look at the options and then test them rather than going straight to this. Because if you look at E, for example, if this is f of x and I take the derivative of this twice, this is clearly not going to work because the x squared is going to go away, right? X squared will go become 2x, which will become 2. So there won't be a 2x. So it can immediately eliminate these two because it's not going to be there anymore. If we look at 3x to the third and take the derivative of that twice, you're going to get 3x squared, then you're going to get 6x. Well, that's not going to work either. You see what I'm saying? It goes x to the third, 3x squared, 6x, and that's not going to work. So it's between these two. And the only difference between these two is it's cosine or negative cosine. So this is where knowing the derivative of cosine is helpful. So if we think about cosine, we start with cosine. The derivative of cosine is negative sine. And then the derivative of negative sine is negative cosine. So that means that if I want it to be negative here, it needs to start off positive. So the answer is A. Okay. So I did that by taking the derivative of cosine and saying, okay, when I take the derivative twice, it turns it negative. Okay. Next one, a bug begins to crawl up a line, got the velocity, what's the total distance? Total distance, key here, not displacement, total distance. Total distance means all of this area plus all of this area. Both need to be positive, absolute value of everything. So the area of this, let's say that's 6 right here, this is 4, this is 4, this is another 4, and this is 1 by 2, which is 1. So altogether, no, sorry, this is 3 by 2, my bad. This is 3, this is 3, and that's 1. So it's 13. 3 plus 6 plus 3 plus 1 is 13. Again, you're adding this area, not subtracting it, because total distance means integral of the absolute value of velocity. Okay. Nearly there. a lot quicker on the non-calculator part. The temperature inside a house T hours after midnight T equals 0 is given by the twice differentiable function h, where h of t is measured in degrees Fahrenheit. Which of the following is an interpretation of the expression h of 0 plus the integral from 0 to 8 h prime of t dt? I think it's good to like not even look at the options, because I think some of these options just confuse you and like, you know, they're not that helpful. H of 0, I know what that is, but that's the temperature on the side of the house, because I know that because it tells me it here. H of 0 is the temp at midnight. That's what that means. So I've got the temp at midnight, I've got the initial value, right? Plus the integral of the rate. So this will give me the change in temp. Change in temp from 0 to 8. That's what that's going to give me. Which means that if I have my temp at midnight plus the change in temp from 0 to 8, now I have h of 8. I have temp at 8. So it is A. Let's talk about the other ones. The average temperature, it doesn't make any sense. We haven't, yeah, it does not make any sense. Average temperature, we haven't covered average value even yet. So that's totally wrong. The change in temperature. So this part right here is the change in temperature. But since you're adding that initial value, that's why it's giving you the temperature at 8. Okay. This C is nearly right in a way because it describes this one. But because of this part at the beginning, it's not correct. And again, average rate of change does not make any sense at all. That one's totally off. Okay. P of t models the population of the world in billions of people, where t is the number of years since January 1st, 2010, which the following is the best interpretation of p prime of 1 equals 0.076. So p is giving me the population, so p of p prime should be giving me the rate of change of population, right? So I immediately know that. And this 1 in here, t is the number of years since 2010. So p of 1 must mean 2011 because a t is a year, right? So if t equals 1, that must mean 2011 because it's years since January 1st, 2010. So let's look at the options. On February 1st, 2010, the world is increasing at a rate of this. Doesn't make sense because we're counting in years since 2010, not months. If it was months, this might be right, but it's not. It would be right? On January 1st, 2011, the world was increasing at a rate of 0.076. That is correct, right? Because p prime is the rate of change of the population, which is right here. And it makes sense to be 2011 because 1 is 1 year after 2010, which must be 2011. Let's keep going. This is incorrect because of that prime. That prime indicates rate of change. If there was no prime, this would just be p of 1. That would be accurate, but this is not right. Yeah, this is just not close. Average rate does not make any sense. That would be just doesn't make any sense. That would be a totally different formula. When the population was 1 billion people, the population of the world was increasing. Yeah, it doesn't make sense because 1 is not measuring billions of people, it's years. This one would make sense if the t was something else, but that's not right. Okay, so it must be B. Last one. A particle moves along the x-axis so that at time t greater than or equal to 0, its position is given by x of t equals a long equation. At what time t is the particle at rest? So you're at rest when velocity equals 0. So first you have to take the derivative. 6t squared minus 42t plus 72. And we need to find where this is equal to 0. We've been doing this in class right now, so you know how to do this. Take out a 6 out of everything. You're going to get t squared minus 7t plus 12. 6 two numbers that multiply to get 12, sorry, put plus there, add to get -7 or -3 and -4. So it must be t equals 3 and t equals 4, which is e. Okay. So let me make that clear. This is v of t right here, which is the derivative of x prime of t. So set it equals 0, factor, solve. Okay, this is FRQ, no calculator. People struggled with this question a lot, and they really struggled. I think this is definitely the most missed question in the entire test, which was a little scary to me, because I didn't think it was that bad. But I think, I mean, it might have been because it was towards the end of the test, it might have been because of the words, but I want to break this one. I want you to pay specific attention to this question when you're revising. Okay, so let's read it together. Start with that. The continuous function above is defined from -4 to 4. The graph of f shown above consists of 2 line segments and portions of 3 parabolas. The graph has horizontal tangents at -1/2, 1/2, and 5/2. It is known that negative f of x equals -x squared plus 5x minus 4 from 1 to 4. The areas of the regions A and B bounded by the graph of f and the x-axis are 3 and 5 respectively. Let g be the function defined as g of x equals -4, integral -4 to x f of t dt. Now you might be tempted just to jump into A, but I think before you do that, it's really important to like break down what this was saying here. So with the horizontal tangents, what that was saying was that at -1/2, and at 1/2, and at 5/2, we have horizontal tangents. These are horizontal tangents. That's what it's saying. It's essentially just saying you have a peak here, right? You have your relative mins and maxes here. Okay, that's what that's saying. Relative mins and max of f, not of g, of f. It's also known that f of x equals -x squared plus 5x minus 4 from 1 to 4. See, a lot of people use this in some capacity, but they didn't use it correctly because they thought it applied everywhere. But this is the only thing that's -x squared. The key here is it's from 1 to 4. So it's only from here to here, right, that we do -x squared plus 5x minus 4. Okay, so that's really key. Before we even begin, just like labeling what up here. Oh, and even more importantly, the areas of regions A and B bounded by the graph of f are 3 and 5 respectively, meaning that A is 3 here and B is 5. I think that really confused a lot of people. Very few people did that. So you should be labeling the graph even before you start answering the questions. Looking based on, especially this is such a big block of text. G of 0, G of 4. G of 0 means plug in a 0 into G. So let's plug in a 0. We're going to change that x to be a 0. We're going to get the integral from -4 to 0 of f of t dt, or f of x dx, whatever you want. And that is going to be the area of this plus the area of this, the signed area, right? So this is a 3 by 3 triangle, 3 width, 3 high. So this has an area of 4.5, right? Because it's 9 over 2. And down here, this is an area of 3, but it's negative, so it must be -3. So the area of this is just 4.5 minus 3, which is 1.5. Everybody could have done this. I don't believe there's any student that could not have done this, but so few did this on the test. And I wonder if it was because of not understanding that it was 3. You didn't know how to begin this, or getting scared by this. And then, so that's a point. This was 1 point. And then we need G of 4, and G of 4 is more challenging. So for G of 4, we're getting the integral from -4 to 4 of f of x dx, right? So we go back to the top. So I need the area all the way from here to here. That's what integrals are. They're areas under the curve, between the curve and the x-axis. So I just need to get the area from here to here. Now I already have these two, right? I already have that. That was 1.5. This one's given to me. That's a 5. This is the one that's going to give me some trouble. So rather than like writing this as like one integral, let's just separate it into chunks because that'll make it a lot easier. So we already know some of this. Integral from -4 to 0, f of x dx plus the integral from 0 to 1 f of x dx plus the integral from 1 to 4 f of x dx. And we know from before that this is 1.5, and we know that this was just 5 because it's 0 to 1. So far I've got that it's 6.5, but I need to add this final area here, the integral from 1 to 4 of f of x dx. That's this right here. And I know that this curve is this function here. So to get this area here, I need to integrate this function from 1 to 4. Let's do that. Integrate from 1 to 4, negative x squared plus 5x minus 4 dx. First step, this is fundamental theorem of calculus part 2. Take the antiderivative. So we're going to do that. Negative x to the third over 3. This is the reverse power rule. Plus 5x squared over 2 minus 4x from 1 to 4. So already, by the way, counting the points, this is 4 points. Doing this separation right here, that's 1 point. That's a point right there. Finding the correct antiderivative here, that's another point. You're already 3 out of 4. So even if you just got to this point, even if you didn't get the correct answer, the fact that you got to this point here, you're already 3 out of 4, which is excellent. To get the fourth point though, you need to get the final correct answer. So we need to evaluate this. The next step from here is that we need to do basically f of 4 minus f of 1. So we need to plug in a 4 into that and plug in a 1 to that. Let's do that over here. And you might be scared by this because it's quite a chunky problem. When I plug in the 4, you'll see what I mean. Like it looks kind of overwhelming, but remember that you don't need to evaluate the function. Like you don't need to simplify in the non-calculator section. You can just put it in a form that could go in a scientific calculator and you'll get the points. So don't let that put you off. So when you plug in the 4, I'm moving over here, if that wasn't clear. I'm kind of low on space, sorry. That's a 16 right there. That's what happens when I plug in the 4 and the 1. And like that's really messy, right? And like you're gonna have like 64 over 3, and it's not like pretty. So I'm just gonna copy it here and show you what I mean when I say like you can just simplify it. So you could just write it as this. That's fine. This would have been your last point. That would have been fine. Okay. The correct answer to this, if you were to evaluate this, is 11. That's it. Moving on. Sorry, one little mistake here was this plus. There should have been a plus here and a plus there. That's it. Otherwise, good to go. Moving on. Most everybody did a lot better on this page, and I think we're able to salvage some points. First question was find all the critical points from -3 to 3. So that's from here to here where all the critical points. Well, that happens. Again, you did have to put this, which people didn't do. But critical points happen when the derivative of g of x, which is f of x, equals 0. You should have put that. This right here, it should have been put there. And that's a point. And then, so where is that? Well, that's at x equals -1, x equals 0, and x equals 1. These are all our critical points because g prime of x equals f of x equals 0. So that's answering the first part. And then are they relative min, relative max, or neither? Okay, well, x equals -1 is, if we look here, it's changing from positive to negative. So we say is a relative max because g prime of x equals f of x changes from positive to negative. Okay, that's one of them. X equals 0 is a relative min because g prime of x equals f of x changes from negative to positive. And then lastly, x equals 1 is neither max or min because f prime of x, g prime of x equals f of x does not change signs. Language here was really important, guys. I think some of you may have correctly identified relative max, relative min, and neither, but you definitely didn't write this in this language. You've got to put this. You can't say it changes from positive to negative. It changes from negative to positive. You can't say that. You have to say what are you talking about? You're talking about the derivative. It's because the derivative changes from positive to negative. That's why it must be relative max, and so on. So make sure you're very, very specific. This was so important to the question. Okay. Lastly, find all intervals on which the graph is concave down. Give a reason for answer. So, the prior knowledge you need is that it's concave down when the derivative is decreasing. So where is that happening? It's decreasing from -2 here to -1/2, and it's decreasing from 1/2 to 1, and from 5/2 to 4. So down here, my intervals are going to be, let me highlight that even. This to this, that's decreasing. This is decreasing. This is decreasing. Those are the decreasing points. So my intervals would be, I would say, G is concave down on intervals -2 to -1/2. Continue down here, 1/2, 1, and 2.5, 4. Because, there has to be a because, give a reason right there, because g prime of x equals f of x is decreasing on these intervals. That's it. Hey, go back to this one for a second. No, I'll go back to this one.